in the last class we discussed a few points on the weed management, and in this class again we are going to discuss some of the other things what we could not able to discuss during last class. So this was the weed definition. I have given there are many number of definitions given by many societies and other persons worked on the weeds. So one of the important definition
sorry sir, but slides are not moving.
No.
Yes, please.
It is in a slideshow mode, sir. Hello. Is it slideshow, sir, mode?
No, sir, no.
No, okay.
Okay, please continue. Slides are visible.
No, sir, just I will try.
Okay.
Sir, now?
Yeah. It's okay now.
Yes, sir. So this is the one of the important weed definition. That is, weed is the plant in a given situation which is more detrimental to the agriculture than the beneficial. So then one more, the important definition given by the father of that weed science is, weed is a plant growing where it is not desired. So friends, weeds are known for their many destructive losses towards the crops. So these things we discussed in the last class. Weeds are the major biological entity which affect the crops mainly due to competition for different growth nutrients. So there are called natural resources. Then if you look at the loss, weeds compete with the crop for water, nutrients, sunlight and space. Then also they act as alternate host for the insect and diseases, provide shelter for rodents and reduces the crop produce. So these things we will discuss in detail. So first, if you look at the crop yield reduction, so it is estimated that annually weeds loss in India is about 11 billion in 10 major crops, and loss range between 13 point to the 35% in the different field crops. So the weed loss is major loss what we discussed, so that can reduce the crop yield up to 35%. So then this affects directly as well as indirectly. So then one more thing is, weeds increases the cost on pest and disease control, because if you look at the example, the weeds like Chenopodium album, which acts as an alternate host for the chickpea caterpillar. So obviously that increases the cost of cultivation to control the pod borer in chickpea. Then that reduces the land values. Weeds also known to reduce the land values. For example, weeds like Cyanidon dactylon and Cypress rotundus, they become noxious weeds and reduces the land quality also. Then one more thing is, weeds also known to reduces the human efficiency. They cause health hazards. For example, weeds like Mimosa pudica, Argemone mexicana and Tribulus terrestris weeds, they affect the human comfort and reduces the work efficiency. They also minimize the aquatic ecosystems. Then they also affect the fishing, boating, tourism and reduces the aesthetic value of the surroundings. So these are the different means through which weeds affects the crop yield as well as the nearby environment. So this is the weed classification. So there are a number of classifications of weeds. So if you look at some of the classifications based on the life cycles, we can classify weeds as annuals, perennials as well as biennials. The annual weeds completes their life cycle within a 1 year of one season. So for example, weeds like Camelina bengalensis and Amaranthus, they comes under the annual weeds. Then second weeds is biennials. Biennials, they takes 2 years or 2 seasons to complete their life cycle. So the weeds like Dacus carota and Allium canadens, they comes under the biennials. Then next one is perennials. These weeds take more than 2 years to complete their life cycle. For example, weeds like Cyperus rotundus, they are the perennial weeds. If you look at the weed share, more than 50% of the weeds belongs to perennials. So most of the weeds are perennial in nature. Then 40% of the weed population belongs to annuals, and biennial weeds are comparatively less. They are 10% in share. So most of the weeds belongs to perennials, followed by annuals and biennials. Then next classification is based on the cotyledons. So based on the cotyledons, we classify weeds as a monocots as well as dicots. Then based on the morphology, classification is most familiar one, and we widely accepted it. So this classification based on morphology is grasses, broadleaves, and sedges. Then next classification is based on the habitat. For example, based on the habitat, we classify weeds as a cropland weeds. Within cropland weeds, some of the weeds are known to occur in dryland situations. For example, weeds like Tribulus terrestris and Xanthium stramurium, they known to affect dryland environment. Then grassland weeds, wetland weeds. For example, weeds like Portulaca oleracea and Centella asiatica, they comes under wetland areas. Then weeds also come under wastelands. For example, weeds like Prosopis julifera, Lantana camera, and Calostropis, they known to occur in wastelands. Then weeds also specified for plantation crops. For example, Epetorium. Then for some of the weeds are forest weeds. For example, Lantana camera. Then weeds for aquatic areas. Within aquatic weeds, some of the classifications based on floating weeds, submerged weeds, and emergent weeds. Floating weeds. These aquatic weeds float on the surface of the water. For example, Icornia crassipus, that is popularly known as water hyacinth, and Salvinia molesta. Then submerged weeds. Some of the weeds are submerged in the water bodies. For example, Hydrilla verticella and Velisneria. Then some of the weeds are emergent weeds. For example, Typha angustata and Colocasia and Ipomia carnea. So next classification of the weeds is based on the origin. Based on the origin, we classified weed as introduced or exotic weeds. These exotic weeds are also called as alien weeds. Then some of the weeds are native weeds. Then again, if you look at the examples for exotic weeds like Parthenium, that Parthenium weeds we introduced to India during 1960 while importing food grains from other countries. Then water hyacinth, we introduced weeds as a ornamentals, but now that becomes problematic. Then Lantana camera, that also we introduced Lantana camera as a ornamental plant from some other countries, but nowadays that became weed. Then most of the weeds are native weeds. Then based on the association to the host, we classify weeds as a crop bound or parasitic weeds. For example, Aravanke and Striga. These parasitic weeds are crop bound weeds. They mainly depends on the host for the nutrition and some other growth substances. So these weeds always associated with the host plant. For example, that is Striga, that comes under sorghum. Nowadays, this Striga also coming in case of sugarcane. Then Orobanke, which is major weed in case of solanaceous crops, that is brinjal, and then tobacco. Then crop associated weeds. So these weeds are mainly associated with the crop for specific microclimate. So difference between crop bound weeds and crop associated weeds is crop bound weeds are growing mainly from the host weeds, that depends host weeds for the nourishment as well as nutrition. But in case of crop associated weeds, here weeds are just growing along with the host, mainly because of some microclimate. So without crop, these weeds can grow, but it is not so in case of crop bound weeds. So crop associated weeds.
Hello, sir.
Sir.
Slide is on broadly viewed only. This is okay.
Yes, sir. Yes, sir. See, this is some of the extra matter, sir.
Okay. Please continue.
Yes. Then crop associated weeds, for example, cuscuta in looser. So then crop associated with some more examples like Phalaris minor in wheat. So this Phalaris minor always associated with the weeds because of the similar growing conditions. For example, other examples like Echinoclova crucially in case of rice. And then one more classification of weeds, that is based on the soil preference. Some of the weeds are known to prefer acid soils, though those weeds are called as acidophiles. For example, sorghum arbensis and Rumex acetosella. Then some of the weeds are known as basophiles. For example, Taxacum stricta, and neutrophiles, some of the weeds. Then some of the other specific classifications on weeds, that is ephemerals. So ephemerals, as we know, ephemerals are the plants which completes their life cycle within a short period of time. So some of the weeds comes in ephemerals because these weeds complete their life cycle even in adverse situations. So that's why weeds carry their generation fast. So they multiply themselves fast. So suppose if water stress is occurring, what they will do? They will mature early and they will produce some seeds and they will forward the generation next. So next seeds will grow and again that proliferate seeds whenever the favorable conditions occur. So this is the ephemeral nature. So that's why weeds are very hardy in nature. They survive under most adverse situations. For example, weeds like Pilanthus niruri, Ageratum conizoides. So these weeds complete their life cycle within 30 to 40 days. Some of the weeds are noxious weeds. These are undesirable, troublesome, and difficult to control. For example, Parthenium and Cypress. Objectionable weeds. Some of the weeds are known as objectionable weeds because the seeds of the weeds and crops are almost similar. In actual, we can't able to differentiate the seeds of weeds as well as crops. For example, Argemone mexicana in case of mustard and ragi. Then some of the weeds are known as satellite weeds. So these weeds resembles the morphology as that of the crop plants. Almost they have same duration and becomes the part and parcel along with the crop. For example, Echinoclova crucially in rice, Phalaris minor in weeds. So these are the different weeds classifications based on their nature, growing associations, and their preferences and other things. So let us look at the one more important thing, that is weed utilization. Here, one side we talk weed as an undesirable plant and unwanted plants. So if you look at the one more side of the weeds are a very good plants which have many favorable characters, such as their medicinal properties, their other soil building properties. So that's why I clearly told in the last class also, weeds are the plants, they are undesirable at the particular situation. So weedy nature of the plants is not a permanent. Weedy nature of the plants depends on our purpose and place. For example, the plants such as grasses, many grasses such as Cynodon, Dactylon. This grass is a weed at a particular crop field. If you look at the outside, this grass can become a very good fodder for the livestock. So like that, weeds have two phases. One, that is because of their superior character, they are adversely affecting the crop yield. But moreover, weeds population has the more potential in different perspectives. So let us discuss one by one weeds utilization. So weeds show a tremendous growth potential, having capacity to produce huge amount of biomass. For example, Parthenium can produce 5 to 20 kg biomass per meter square. Similarly, Cromolena that can produce 9.3 kg biomass per meter square. Then weeds like Cassia, Ceresia that can produce 3 kg biomass per meter square. Like that aquatic weed that is water hyacinth, Icornia crassicus that can produce biomass up to 10 to 11.5 kg per meter square. Similarly, Lantana camera that is forest weed that can produce up to 1.5 kg biomass per meter square. With higher plant nutrient content in their biomass, weeds biomass utilized for various purposes. So here we are getting two advantages. One is higher biomass yield, then in addition that is higher nutrient content. We are getting higher biomass also and higher nutrient content also. So that's why the weed biomass can be utilized for various purposes. So if you look at the weeds, one important benefits is weeds are the source of nutrient for crops. Weeds helps in keeping good structure and structure of the soil. So mainly by adding the soil organic matter and other nutrient contents, because these weeds are rich source of nutrient as well as carbon. Then weeds increases the soil fertility and encourages the soil microbial activity. This is mainly by improving the soil organic carbon. Then weeds act as a raw material for composting. This is one of the major potential we can utilize this in agriculture, that is compost making. Nowadays we are getting shortage of compost raw material. So weeds are the important sources for that. So we can convert the weed biomass as a valuable compost, and that again we can recycle for the crop field. So that reduces the many carbon emissions while preparing the fertilizers, and that also reduces the cost of cultivation. Then weeds can also used as a green manure, mainly because of their higher nutrient content. Then secretion of amino acids, sugars, and growth promoting substances from weed plants in the rhizosphere, that again improves the soil physical as well as chemical properties by improving the soil microbial activity and soil enzymes activity. So weeds contain large amount of nutrients. So here we can look at the weeds can be used as compost, then we can use as green manures, then we can use as a compost, then so this is the green manures. So here you can see the nutrient composition of weeds. So you can see the nitrogen, phosphorus, potassium content. So these the nutrient contents in general, these nutrient contents are 2 to 3 times higher than the any crop residue. If we compare the crops like rice, wheat, maize, so these nutrient contents are 2 to 3 times higher than those field crops. So that's why weeds are the richest source of nutrients. So for example, Parthenum strophoros that contain 2.16% of nitrogen, then 0.5% of phosphorus, and 1.68% of K2O. For example, aquatic weeds like water hyacinth that contains 2.2% of nitrogen, 0.56 K2O, and 2 to 3% K2O. Similarly, Sanedum dactylon that is that contains 2.4% nitrogen, 0.45% is phosphorus, and 2.5% potassium. So if you to look at any grasses and other dicot weeds as well as aquatic weeds, all weeds contain considerably higher amount of nutrients than the any crops. So weeds also act as a food for human consumption. Unknowingly, we are consuming many weeds as a vegetables, green vegetables. So normally farmers use many weeds as a vegetables. For example, Chenopodium album, Amaranthus viridis. This Amaranthus viridis will be prepared by many people. So as a vegetables, they take the tender Amaranthus leaves and prepare leafy vegetable. Then Portulaca species. So this Portulaca species nowadays mainly coming in case of sugarcane. People at the tender stages harvest the Portulaca species tops and they are preparing vegetables. Similarly, Alternanthera triandra, Coccinia indica, Solanum species, Celosia argentea, the etc. used as leafy vegetables. The nutritional composition of Amaranthus viridis leaves. So if you take the examples of the dry leaves of the Amaranthus viridis, here this Amaranthus viridis contains 283 calories per 100 gram. So this is the huge calorie benefit we are getting from that beets. Then protein we are getting at the 34.2 gram fat, 5.3 gram carbohydrate, 44 gram fiber, 6.6 gram ash content, 16.4 gram minerals such as calcium, phosphorus, iron, sodium, potassium. Moreover, you can see the vitamins. Vitamins A, thiamine, riboflavin, niacin, vitamin C. So this is the benefits what we are getting from one weeds. So such a huge nutritional profile these weeds have. So that's why still I don't know in many rural areas people are taking these weeds, few weeds as a vegetables. So in addition to these weeds, commonly people use lettuce type lactuca weeds as a vegetables. They eat as a raw green leaves along with the meals. So then one more potential of weeds is weeds act as a fodder for animals. This is the known fact. Still people are using weeds as a fodder. So these weeds are the important source of fodder for the animals. Mainly because of weeds has a higher nutrient content, so that meets the nutrient requirements of the animals. For example, alligator weeds, that is Alternanthera luxurians, weed is used as a substitute for berseem, jawar and maize. So this is reported from Jabalpur, Madhya Pradesh, by dairy owners. So they are using these weeds in case of in substitute for important fodder crops such as berseem, jawar, and maize. Then Rincosia species and Clitoria ternacea are very good fodder legumes. Similarly, water buffaloes and cow feed on water hyacinth in aquatic aquatic bodies. So buffaloes and cows are feeding on water hyacinth. Then dried and processed water hyacinth is recommended for cattle in southern states of USA. Then the aquatic fish in large scale they are harvesting and drying and further they are using. Then water hyacinth is mixed with paragrasses that give higher calcium as well as phosphorus ratio. Here they are also tried the combination of different weeds in mixture and they got benefits in terms of nutrition. Then weeds like Panicum, Ergotis, Setaria, Distaria, Chloris barbata, and Heteropogon, etc., can be used as a potential fodder crops. So here you are looking different weeds. So this is the weeds potential. So this is the nutrition composition of one example, that is alligator weed. So if you look at the fiber content, fat content, protein content, ash, pectin, calcium, magnesium, phosphorus, total phenolics, total carbohydrates, and total free amino acids. So what are the mineral elements, vitamins we are supplying to the animals from the feeds after purchasing? So those all nutrients and minerals, vitamins can be supplemented through these weeds biomass. So this is the potential of the weeds. So here we can clearly see the nutrient composition. Then organic constituent of water hyacinth, and here if you look at the this how the water hyacinth affects the water bodies. So that contains carbohydrate percent 7.8%, fat and wax 7.7%, lignin, crude protein, crude fiber. Here, these weeds supplying adequate quantity of fiber as well as nutrition also. So here there will not be any problem. Suppose if you take the higher quantity of protein and lesser quantity of fiber, our digestion may be affected. But weeds are in supplying in such a way that they are supplying the all the nutrients in almost balanced proportion. They are supplying all the nutrient and other fiber contents. So that's why there will be no problem of digestion and other things. In many cases, if you take only one nutrients extra, other nutrients may become deficit, and excess quantity of that particular nutrient may become problem. But weeds are not like that. They are supplying almost all the nutrients in a smaller quantity. So weeds are also known to check the soil erosion. So for example, weeds like Saccharum spontaneum helps in the reducing the wind erosion of the soil. Saccharum spontaneum weeds can obviously reduce the wind erosion, and that acts as a wind barrier because of their height. Then weeds like Sonodon dactylon reduces the water erosion of the soil. Here we are seeing that mainly because of their shallow and fibrous root system that binds the soil tightly, so that won't allow the soil to detach that much easily. So that's why that reduces the soil erosion. Deeply leached nitrate can be returned to the upper soil layer by growth and decay of weed soils. So here the important thing is weeds are known to extract the soil nutrient at higher quantity and from deeper soil depth. So that crop could not do. So suppose particular nutrients are deposited at 50 centimeter soil depth. Some of the weeds are known to extract the nutrients from 50 centimeter soil depth. So that could not perform by the most of the crops. So that's why they accumulate those nutrients in their biomass. If you reutilize those biomass, so indirectly we are extracting the deeply leached nitrate in terms of weed biomass, then we are again returning that weed biomass to the upper soil layer. So just we are recycling the nutrient through these weeds. So in that way, weeds have a benefit. Then water hyacinth use in natal to trap a source of fertility. So by adding that as a green manure. Then some of the weeds also tested for the biogas production. Biogas energy assumes special importance with reference to the rural sector. So this some in many areas tried for this potential also. Inadequate availability of cattle dung is the major problem for running the biogas. So in that case, we can use this weed biomass. Then use of weed biomass as an alternative energy for biogas. Then water hyacinth is used as a fuel in Indian villages. Plant is subjected to bacterial fermentation. Then it produces 26,500 cubic feet gas contain 22% CO2, 1.2% oxygen, 51.6% methane, and 25% hydrogen. So that fermentation start within 2 to 3 days because of the better CN ratio of that weed biomass. Then gas production in 15 to 20 days after. So cassia and parthenium is also used for the biogas production. So we can see how weeds we can exploit in future. We don't know nowadays many technological advances are going to happen. So in future we don't know. Suppose if anybody invent these biogas and other things from particular weeds, so in future it is we can't surprise that we can start cultivation of any particular weeds. So that much potential weeds have in positive side. So this is the medicinal values. All weeds have medicinal value. For example, Clium viscosa is used for curing pain of ear. Then Solanum, Xanthocarpum, Datura stramurium, Calostropis procera have medicinal value for animals. Seeds of Tribulus terrestris used to rectify kidney trouble, and Parthenium has anti-inflammatory, anti-tumorous, and angiogenic property. So these are some of the weeds listed in medicinal or Ayurveda, and they are using for different purposes. So there are many indigenous uses of weeds have been reported, and they are using for many good causes. For example, Cassia accidentalis, the root is an antidote to poisonous and used in snake bite with pepper. So like that, there are many weeds, different parts of the weeds such as leaves, stem, even roots, seeds, flower. Many, almost all the parts of the weeds are using to cure some of the major as well as minor diseases and other disturbances. For example, Argemona mexicana, externally for skin diseases. Then this can be also used for stomach troubles. Then Portulaca quadrifida. This can be used in curing low fevers, cough, asthma, eye diseases, and skin infections. So you can see the n number of examples. For example, Solanum xanthocarpum. This can be used in curing asthma, cough, and fever. So like that, some of the many weeds have been reported for their curing ailments. Then what I discussed, weeds acts as alternate host for diseases. So if you look at the examples, diseases harbored by the specific weeds. So again, those diseases or pathogens spread towards the crop field from these weeds. So that's why that increases the cost of cultivation in controlling the particular diseases or insect. So for example, postweed, agropyron, verticillum, and portulaca. Just a minute, sir. Sorry, sir. The weeds like Cenchrus ciliaris that acts as an alternate host for the disease ergot in case of pearl millet. So if you look at the crops, pearl millet, vegetables, these diseases are the major and detrimental diseases in the field crops. So for such diseases, these weeds are acting as a alternate host. For example, in case of rice, bacterial blight is one of the important disease. For that bacterial blight, weeds like Listeria oryzoids, they are acting as a alternate host. Similarly, that is panicum is that becoming alternate host. Then likewise in case of tobacco and tomato, that is the viruses, they are the detrimental diseases. For such diseases, these weeds are acting as alternate host. Similarly, in case of vegetables, that is sting nematodes and Reclon and Listeria species are acting as a alternate host. So these are all the indirect classes causing by weeds to the crops by spreading the diseases by acting as an alternate host. So here one more beneficial of that weeds, this they are using in paper, pulp, and fiber industry. Weeds produce fiber and pulp for the production of paper. Leaves of water hyacinth are bitten directly to make a sheet. Then tiles can be prepared after mixing pulp with cement and whitener. Leaves can be used as a cigar wrapper. Fiber from stem is substitute for jute. Addition of 10 to 8 to 10% of jute or cotton fiber with water hyacinth leaves to prepare paper as well as board. Then cypress, pangori, and cypress corymbosus are good material for making mats. Type angustata can be used for making screen. So here we can see. So it may not be 100% of this weed material. So this weed material can be blended with the cotton as well as jute and other fibers. So that's why in that way these weeds can help in reducing the fiber demand. So that's why these fibers of these weeds can be blended with important fibers and prepare some of the coarse materials. Then weeds also used in silkworm rearing. Weeds extensively used in sericulture to increase the silk yield. Then weeds like Trabulus terrestris and Sorelia Corlifolia increases the silk and yield of mulberry silicon. Solvent extract of lantana camera and clerodendron induce more feeding of worms and bigger cocoon size. So Parthenum is acts as a phagostimulant. So these are the weed benefits exploited in case of silkworm rearing. Then weeds also act as a biopesticides, herbicides. Leaf and root extract of many weeds shows the herbicidal property. Then Parthenum extracted from shade dried leaves, a Parthenium that is contained Parthenin. So purified from the methanolic extraction, sprayed on 2 months old plants of Agratum conizates at the rate of 30 ml per plant. Treated leaf shows less chlorophyll content. So that means the Parthenin extract has the ability to reduce the photosynthetic activity of that Archimona Agratum conizates weed. So as insecticides, many weeds have the insecticidal property, reduces the pest resistance, resurgence, insect and diseases, and environmental pollution. Then utilize the weeds for beneficial purposes, save the money used for managing weeds, alternative host for insecticides. Then the extract of Calotropis procera used against the termite in sugarcane. Obtain that content can be obtained from its leaves by crushing and filtering. Sets were dipped in different concentration of extract. So these are some of the indigenous uses. Then some weeds are known to have mycotoxic activity. Parthenium has mycotoxic effect on some individuals. So again, these symptoms differs from individual to individual. Then similarly, Trichophytum obtained from 32-year-old man suffering from the onychomycosis. So these are some of the residues of these weeds reported in human beings. So the growth of the above organisms in media with. So these are some of the allergic symptoms may occur on human beings. So then weeds also exploited in case of mushroom cultivation due to high cost of wheat straw. Water is used as a media for cultivation of the mushroom. Cassia hirsuta also used for cultivation of mushroom. So this is the detail how they used. So this is not required now. Then these weeds can be also used for reclamation of alkaline soils. So addition of aggregate Argemona mexicana fodder to alkaline soil help in reducing the soil pH. So the reduction of the soil pH may be attributed due to presence of organic acids and sugar to the extent of 4.8 to 9.8%. So this how the natural beauty of the weeds. They are known to reclaim the soils by correcting the soil pH. Argemone powder used in ameliorating the soil and increases the paddy yield due to its potassium and nitrogen content. Organic acid is released on decomposition under flooded conditions. Then one more important use of weeds is wild weeds serve as a gene pool in breeding of crops. So weeds have many positive traits, so we can explore these traits in breeding the field crops. For example, Secunum spontaneum, wild ragi, wild rice. So these wild types have many positive and hardy natures. So we can transfer these hardy nature or traits to the into the crop fields. So crop can perform better yield even under adverse situations such as weeds. So in that way, weeds have a greater potential. Then in case of pollution abatement, aquatic weeds reduces the toxicity of water. Then Chenopodium album is very sensitive to hydrogen sulfur and sulfur oxide. Then wild mustard is sensitive to ammonia. Then water hyacinth absorbs heavy metals and organic substances. Then they also absorb ammonical and nitrate form of nitrogen and phosphorus for decaying plants. So far we discussed the all possible benefits of the weeds. So let us look at the problems on utilization of weeds biomass. So far we discussed the positive side of the weeds and their potential uses. So in spite of there are many uses. So far the weeds utilization in agriculture is not that much common. Few people are using, and that is not the common practice. So there are some of the problems associated with the utilization of weed biomass in agriculture. Are weeds compete with the crops for nutrient, moisture, space as well as light. The weeds take 1/3 of the applied fertilizers in first 3 weeks. Then weeds remove 1250 tons of water in a season from 1 hectare. Then weeds compete for the light due to reduction in the photosynthetic rate of the crop plants, health hazards in human beings and animals, viability of weed seeds in the field. So the weeds as hazardous to human health. That's why it becomes difficult to handle these weeds. They can cause allergies, poisoning, itching, and hay fever. Then chronic to human illness and suffering. Argemona mexicana seeds mixed with the mustard seeds, they can cause death of people because of the chemical sanguinarine and 11 oxotriaconetic acid. So these are some of the contents in those Argemona mexicana seeds that can cause death in people. Then dense perennial snake weed stand reduces 70% of the grass production. Then Parthenium problem. Children below 12 years more sensitive, followed by the teenagers and above ages. That can cause the skin allergies. So these are all the problems of the weeds associated with the weeds handling. Then points we can remember few points from these discussions on weed biomass utilization are weed biomass can be used as a bionutrients in the form of green manure and compost, which enrich the soil fertility and alternative for synthetic fertilizer. This is one of the potential use we can practice in agriculture in near future. Then extract of weed biomass used to control weeds, pests and diseases and reduces the synthetic pesticides. Then biogas energy assumes special importance with reference to rural sector for the weed biomass for biogas production. Then fuel, wood, fodder and raw material for household media for mushroom cultivation and preparation of medicines. So this is the so far we discussed on the weeds positive potentials and their problems also. Then now we can have open the discussion on one of the important concept that is we need to know from the point of crop yield losses and weed competition, that is crop weed competition. So crop weed competition by name itself suggests crop weed competition. This is the competition between crops and weeds. So here we need to know how this occurs, why it occurs, then what are the factors which decides the crop weed competition, then what is the importance, then what is the period of crop weed competition in different crops, and what are the importance. So this crop weed competition is very much important in case of weed management. So in crop weed competition, one more important term is critical period of competition. Critical period of competition. So if you look at the term, time when weeds are most likely to reduce the crop growth and yield. This is the critical period during which weeds reduces the most of the crop yield. My name itself suggests this is the critical period. So in that period, we have to go for weeding. Otherwise, our crop loss will be more. Generally 1/3 to 1/2 of the life cycle of the crop is critical. Period is the critical for crop yield competition. Control at the seedling stages to closure of canopy. The yield reduction 40 to 96% across the rice ecosystems. Here, one more term is critical threshold level. Maximum density of the weeds which the crop can tolerate without causing significant yield or biomass reductions. So critical threshold level. So this level we have to decide based on the research and problems of the weeds. So this threshold level is the, so this is the maximum number of weeds that can be tolerated by the crops. So even up to that number of weeds, the yield loss will not be significant. For example, threshold level is 4 for Icornia crassipus in some other words. That means even up to 4 weeds are there in that particular crops, though yield reduction will not that much. So that is the meaning of threshold level. Rice can tolerate below 25 weeds per meter square in case of cypress. Then Echinoclova species are grasses at the threshold limit is 5 per meter square. If 5 weeds are there per meter square, that can cause yield reduction up to 9%. So this is the meaning. So here you can understand the critical weed free period. So here you are looking at the crop yield and the days from crop emergence. So this is the crop, blue lines indicates the crop yield. Then this green line indicates the weed competition. As weed competition increases, crop yield drastically reduces. They are negatively related. So the first stage is the seedling stage. In seedling stage, the competition from weeds is very much less. That's why the crop performance is independent, and that is at the highest level. As the crop growth increases, crop growth duration increases, if that weed competition also increases. As weed competition increases, the crop overall growth that reduces to the maximum. After some time, weed competition also attains some level and crop yield also attains some level. After that, there will not be yield reduction. So this in between period is period 1 is the seedling stage. Here also there will not be any competition between crops as well as the weeds, because they are smaller in size. They grow independently. So in the period 2, it is the grand growth period for both the weeds as well as crops. Both they will try to exploit the resources from the soil and the atmosphere. So in that case, both will compete each other, and performance of the crops will obviously affected, because weeds are genetically as well as inherently superior in many characters such as better nutrient uptake efficiency, their biomass accumulation, and their hardy nature. So they suppress the crop growth and grows better. So that's why the crop yield drastically reduces. After some time, suppose crop attains maturity. After attaining crop maturity, if increase the weed population, there will not be any reduction in the yield. So yield level will be same. So that's why period 3 is also not important for us. Here weed interference will not impact the crop yield. In the first stage, weeds and crops are not at all competing. Okay, so this period 2 will be the critical period of crop weed competition. Means in the period 2 only we have to go for weeding for better crop yield. If you take up weeding in period 1 and period 3, there will not be yield difference. Only the important period for weed control is period 2. So that is the critical crop period competition period. Okay. So if you look at the examples in different crops, critical period of crop weed competition and yield losses caused by weeds in different crops. So the crops like rice, in case of direct seeded rice, the critical period is start from 15 to 45 days after sowing. If you don't take up weeding at this period, the yield reduction, the grain reduction is up to 50 to 90% in case of direct seeded rice. Whereas in case of transplanted rice, the critical period of crop yield competition starts from 30 to 45 days. So the yield reduction is 15 to 40%. The yield reduction is less in case of transplanted rice, because because of the puddling and continuous water stagnation, many of the weeds themselves die in puddling operation as well as in flood situation. So the yield reduction is also less compared to direct seeded rice. If you consider the wheat, the critical period is start from 30 to 45 days. The yield reduction is 20 to 40%. In case of maize, it is 30 to 45 days. After sowing, then the yield loss is up to 60%. In sorghum, again up to 45 days, the yield reduction is up to 40%. In case of bajar, that is pearl millet, the yield reduction is up to 60%. In case of pulses like pigeon pea, the critical period of competition extend up to 60 days because of the initial slow growth of pigeon pea, and yield reduction will be up to 40%. Then in case of green gram, critical period of fluid competition is up to 30 days. Then reduction in grain yield is 25 to 45%. In case of black gram, this is short duration crops up to 30 days. 15 days is the critical crop yield competition. Then yield loss up to 50%. Similarly for cowpea, chickpea, peas, the yield reduction up to 30%. So this is the important things we need to consider while planning weed management practices this period. Then this is the just another additional information I discussed earlier, that is weeds acts as an indicator for poor growing conditions. So if you look at the weeds such as red sorrel that grow in low soil pH, that is in acidic condition. If red sorrel population is highest in that particular soil at that location, we can clearly say this location is having low soil pH. Similarly, plantains that grows in case of high soil pH. Then in case of drought soils, then prostrate, spurge, black medic, knotweed, wood sorrel, and bracted plantain. Then in case of wet soils, many weeds such as sedges, then goosegrass. Then in case of poor sandy soils, weeds like pikegrass and sandspur. Then in case of high nematode situations, weeds like spurges, parsley, and knotweed. In case of compacted soil, weeds like goosegrass, poyano, and knotweeds. In case of low soil nitrogen, legumes and yellow snakeweed. In case of high soil nitrogen content, grow even at high pH condition, low pH condition, high nitrogen content, can survive. So that's why compared to crops, they are well past the survival of the pitted test, and that's why they are inherently stronger or hardier than the crop plants. So that's why easily they will take the upper hand over the crops. So here one more thing is when weed becomes a problem. So this basic thing. So these are the weeds. If they get favorable environment, then susceptible crop, then weed seed ban. So these are the three main things. Because of that only weed become a problem. First one is weed seed bank. So all our management practices should concentrate on these three things. Then we have to think how we can manage these three things in favor of crops. So first one is, for example, weed seed bank. If you manage the weed seed bank and if you produce the less weed seeds, so obviously weed problems will be reduced. So if you produce plenty of weed seeds, then there will not be any use. After sometimes weeds will become emerge. Then one more is susceptible crop. So in many management practices, we suggest that we should select crops and crops varieties which have better initial crop growth, initial crop vigor. So they can reduce some extent of the weed problems at the initial stages. Then favorable environment. So this favorable environment we create the crops by taking up intercropping and some other activities. So here we can see weed seed bank. So what is the weed seed bank? Weed seed bank is defined as the sum of the viable weed seeds and vegetative propagules that are present in the soil. Thus, they contribute to the weed pressure in future crops. So, there is a one popular and common saying in weed management, that is 1 year weeding equal to 1 year seeding equal to 7 year weeding. 1 year seeding equal to 7 years weeding. So 1 year, if we allow weeds to produce plenty of seeds, the weeds produce plenty of seeds and the seeds will be deposited in the soils. So after that, we need to remove those weed seeds. That takes 7 years to remove those weed seeds, because suppose a particular plant produces 1 lakh seeds. Those 1 lakh seeds will be deposited in the soils. So 1 lakh seeds will not germinate at a time. In 1 lakh seeds, 10,000 seeds will emerge for this season. Then 10,000 seeds will remain dormant. Then next year again 10,000 seeds. Few seeds are remain dormant for 2 to 3 years. Like that, staggeredly they will germinate because of the varied dormancy of the weed seeds. So, if suppose the 1 lakh seeds are deposited in the soils, those 1 lakh seeds will not germinate at a time. They will germinate in 5 to 6 times. So that means once if you allow weed seeds to deposit, we need to remove weeds for 7 years of the period. So that's why 1 year seeding equal to 7 year weeding. So that's why that is the importance of the weed seed bank. Then agricultural soils can contain thousands of weed seeds and a dozen or more vegetative propagules per the square feet. This is the common feature. Then weeds are the prolific seed producers, as I told. For example, Amaranthus panosus that produces 1,96,000 seeds per plant. Similarly, Commonlena bengalensis, that is 25,000 seeds that produces. Then Decluptinium aegyptium that produces 66,000 seeds per plant. Similarly, Lucina indica that produces 41,200 weeds per plant. Then Portulaca oleracea that produces 10,000 seeds. So this is the weed seed bank dynamics. Sir, shall we have 2 minutes break, sir, please?
Yes, sir, sure.
Yes, sir. Thank you.
Meanwhile, among the participants, those having any query, they can put their questions in the chat
Yes,
box.
sir. Yes, sir. Just 2 minutes for me.
Yes, yes, yes. You
Okay.
can. You can.
Okay.
Or if anybody want to ask, they can unmute themselves. We will allow you to
Hello,
talk.
sir. Hello, sir.
Yes.
Yes, please.
सर
Kadam,
सेम
please.
हाँ यस सर सेम विडची डॉर्मन्सी सेम राहते ना
Weedची dormancy
सेम स्पेसिसची विडची डॉर्मन्सी सेम असेल तर मग ते जास्त दिवस म्हणजे काही सीड
please either you talk English or in Hindi, please.
I'll
Yes, sir, please.
So he want to ask about every weed species having same dormancy or not.
No, sir, weeds are different in their weeds and dormancy. In no case all weeds have similar dormancy.
Yes.
All weeds have different dormancy. One more interesting thing is, sir, even in the single weed plant, suppose this is the panicle of the weeds. So in the same panicle only, upper portion of the seeds in the upper portion of the panicle has a different dormancy, and seeds in the lower portion of the panicle and in middle portion of the panicle has a different dormancy period. So that is the diversity with respect to weeds. So that's why weeds dormancy is not same for all the weeds, even in the same plant also. So that's why they germinate in a staggered fashion.
Okay. Yes. Is that clear to you? Kadam?
Yes, clear.
Okay.
Thank you, sir.
Okay.
Hello, sir.
Yes, Lokesh, please.
Sir, Arjun Mexicana, how will it improve the study yield, sir? I don't know.
How it?
What is the mechanism they involved there?
Mechanism for what?
Study yield increase.
Okay. Yes, paddy yield increase, na? So, Arjimona mexicana, that is some of the nematocidal property and other decomposition of that Arjimona mexicana releases some of the particular enzymes that helps in controlling some of the pest diseases as well as insects in nematode. And more than that, that adds some of the nutrients through that biomass decomposition. So because of three things, one is by adding the soil nutrients and one more by controlling the diseases. So in that matter, that increases the paddy yield.
Okay, sir.
Okay, thank you.
Anybody from other participants? Jyoti, you want to ask something?
No, sir.
Okay.
You can also write at the chat in the chat box, so we can discuss later also. There is no problem.
Yes, sure. Not in this case also, you can also ask any type of
Yes.
questions,
No issue, sir.
any type of query.
Yes, sir. So
At the end, we are also providing the recordings. Those who can't attend the sessions
yes, sir.
to do their.
Sir, actually, just in general, I can suggest the students. So, whatever the lectures covering from the different experts, so you just whether it is related or somewhat it may be not related now. So you just listen the lecture, because in many JRF, SRF as well as JRS questions, some of the questions will be asked unrelated only. So in that case, if you hear the lecture here, so some of the points will be stored in your brain. So in that condition, you don't feel that I have not heard this. So
Yes.
in many questions, you can answer just by hearing somewhere. So such questions definitely you can answer from such lectures. So that's why always, if you are getting any lecture, so you just listen. So these are all the basic things for you people. So
We are also providing, sir have given the 3 question papers. Already
yes.
7 question papers I have received from one expert. We will share at the end, but you go through all these.
Yes, sir.
Okay.
Sir, now your our students are showing much interest, sir. So we are also feeling to visit your university once, sir.
Okay. So at that our time, many JRFs are there.
Yes, sir.
But due to these banking sections and other
Yes, sir.
opportunities, they are shifted over there.
Then no problem, sir. Yes,
Prajwal.
Sir, shall we start, sir?
Okay. Please continue.
Yes, sir. So friends, here is the wheat seed bank dynamics. So just you can see here this. Some of the this is the fate of the wheat seeds. So after production of the wheat seeds, what will happen? So this is the soil. So some of the seeds in the soils are dormant seed bank. Then some of the seeds are non-dormant. So non-dormant seeds, what they will do? They will germinate immediately and they will die. Okay, they will produce seeds and again they will die. Then some of the seeds germinate and they are live. So in case of crops also, the non-dormant seeds, some of the seeds will germinate and immediately die, and some of the seeds are germinate and they live and again they produces the seeds. Then again the after seed production, seeds rain, we can call seeds rains because wheat seeds produces huge quantity of seeds. Again seeds rain is again deposited in the soil. Then non-dormant seeds, what they will become, then non-dormant seeds can be predicted by the birds, mice and insects. Then some of the seeds can also decay in the soil by action of the pathogens as well as fungi. Then seed dispersal mechanisms, you know the seed dispersal mechanism. So that is by the rain, that is by the wind, animals and machinery. So that is these are all the agents of the weed seed dispersal. If the water is involved in the weed seed dispersal, that mechanism we can call as hydrophily. If animals are involved in the weed seed dispersal, that mechanism we can call as geophily. Then if air or wind is involved, that mechanism we can call as anemophily. This wind is the major mechanism of weed seed dispersal, that is anemophily. So because many weed seeds are light in weight and also they have specific features such as hairs and balloon-like structures. So through these weeds, through this wind, these weed seeds can float kilometers together. So wind is the major mode of weed seed dispersal. Then many times man also involved in the weed seed dispersal. That mechanism we can call as anthrophily. So just I am telling for your knowledge, that is weed seeds modification for wind dispersal. Weed seeds, some of the weed seeds produce pappus-like structure, means parachute-like structure on the weed seed. So through that parachute-like structures, weeds can float to different distances. For example, Tridax procumbens, that weeds belongs to Astraceae family, that produces a parachute-like structure. Then comos type of mechanism is, that is seeds are covered with the special hairs. For example, here you are seeing the weeds. Weeds are covered with the special types of hair structures. So for example, weeds in case of calotropis. So through that hairs-like structures, those weeds can travel longer distance through wind. Then balloon-like structures. Some of the weeds have modification by producing the papery calyx in case of Physalis minima. Then winged fruits, seeds light in weight and disperse with wind storm without any special arrangement. For example, striga seeds and orobanche seeds. Interestingly, if you take the striga seeds, the weight of 1000 striga seeds is just 0.2 gram. 0.02 gram. 0.02 gram is the weight of 1000 striga seeds. Means those seeds are that much light in weight. So that's why they disperse through wind very easily. Okay. So this is the weed seed mechanism and weed seed bank mechanism in the soil as well as weed seed dispersal. So this is the annual weed population model. Soil seed bank that becomes seedlings, mature plants again that produces the seeds. Then this is seed fades and again seed production. Then huge gap between weed seed production potential and seedling emergency exists. So as I told, after weed seed production, some of the seeds emerges and some of the seeds will not emerge. So if you look at the example, Digitaria marginata, number of seeds per meter square is, that is 90,000 seeds will produce. Out of that 90,000 seeds, seedlings emerged in different depth. In case of top 15 centimeter depth, only 1500 seeds will germinate. That is percentage is hardly 2%. Means 80% of the 98% of the seeds will remain in the soil, only 2% of the seeds will germinate. Means among 90,000, just 1,500 seeds will germinate, and remaining seeds will be in dormant condition in the soil. Similarly, in case of Ageratum conizoids, nearly 11.5 thousand seeds will produce per meter square area. Among 11.5 thousand, only just 166 weeds will germinate. Only 166 weeds will cause huge problem to the agriculture. If you just imagine all 11.5 thousand seeds will emergence, what will be the fate? So just we are struggling very hard to manage only 2 to 3% of the weeds emerged. So remaining 90 to 98% weed seed bank is there in the soil. So this is the huge difference between weed seed produced and weed seed emerged. So weed seed longevity, that means period up to which weed seeds are viable in a dormant state. This is also one of the major character which helped weeds to take upper hand over the crop always. So in case of perennial ryegrass, weed seeds are remain viable for a period of 3 years. In crops also, we can find some of these seeds will remain viable for 3, 4, 5 years, but not more than that. Okay, after 3, 4, 5 years, crop seeds may become damaged, or they can, in case of hybrids, almost they will lose their viability and their original feature. But in case of weeds, in case of annual ryegrass, the seeds are remained active or viable for 9 years. So in case of adverse situations, that is mustard, wild mustard, that is up to 600 years. Then lotus, that is up to 3,000 years. Then lupin. So this is the beauty and adverse nature of these weeds. So that's why always they are superior in terms of the competition. Weed seed bank management practices. So some of the weed seed bank practices are, there are many, just I am telling in general few things to remember for you. Kill weeds before they set seed. This is one of the simple and best effective management practices for the weed seed bank. Only thing is, kill the weeds before they set the seed. So weeds can be used as a better source of organic matter before setting the seed. If you use the, if you control the weeds before setting seed, that can be used as a very good organic matter. So after setting the seeds, again that is very difficult. Then control the creeping perennial weeds before they can form a new rhizomes and tubers or other propagules. In case of perennial weeds, so we can control the perennial weeds before setting the rhizomes or planting materials, that is tubers or propagules. Keep crops ahead of the weeds. Small weed overshadowed by the good crop canopy may have less than 1% of the seed forming capacity of vigorous individuals growing in fruits. Means keep crops ahead of the weeds. Means crop should be sown timely, and crop should cover the land before weeds emergence. Once crop covers the canopy, obviously weeds will be shaded by the crop, then weed growth will be reduced. For example, in case of coffee can be used as a cover crop, mainly that covers the ground fastly within a short period of time. So that's why weeds will obviously shaded by the coffee, and their growth will be less. So this is the cultural and management practices. So walk fields to remove large feed escapes before they flower. Getting the largest 10% of the individuals can reduce the production by 90% or better. So this is the vigilance of the farmer over the weeds. That is, we have to continuously observe the weeds for the seed production. Suppose any weeds attaining seed maturity are there, it is starting seed production in a flowering stage, we need to remove that weeds. That work will be 10% only. That 10% weed control work will reduce the weed seed production by 90%. So suppose if you control the weeds before seed production, that means we control remaining 90% of the cause. So that's why controlling weeds before setting seed is very much important. Then graze fields promptly after harvest to interrupt the weed seed production. This is some extent this can also reduce the weed seed bank. That means after harvest of any crop, some of the weeds in mature stage remain in the soil. So in that case, you can allow animals to graze. So animals will eat the weed plants completely along with the seeds. That means weeds seeds will be eaten by animals. So by that way also you can reduce the weed seed bank. Then utilize good sanitation process practices to prevent introduction of new weed species into field and remove new invaders before they propagate. So suppose if any new weed is finding in our field, that is some strange we are finding. So before setting the seeds and before that mature, we need to remove it clearly. Otherwise, in future, that weeds become a major threat. So these are the general practice principles of weed control. Just I am mentioning prevention, control, and eradication. Here in weed management, eradication is somewhat practically impossible. So that's why control and preventions are the better options we have. So many times prevention is the better than cure. That strategy also works well in case of weed control. Then these are the weed control methods. Some of the just options I have listed. Cultural methods. Cultural method that includes tillage, planting method, varieties, planting density, fertilizer application, irrigation and drainage, cropping systems, and growing up cover crops, sequence crops, mulching, whatever the crop management practices we can think, those all comes under cultural methods. Okay, so all cultural methods have their different set of practices and different importance. So just I am telling that in case of varieties, so variety using a suitable variety that is less costly matters. Anyway, we are using some variety for this sowing. So better we have to think and select the variety which has better competitive ability. These are all the non-monetary inputs. So if any variety has a initial vigor and initial growth, so by that only we can reduce the weed density and weed incidence up to 40%. So that is the important of the culture practices. Then one more thing is planting density. In many cases we forward the optimum plant density, and many times we go for wider spacing that is not required by the crops. So in that cases weeds will grow and that take the upper hand over the crops. Then similarly, irrigation and fertilizer management. As you know, fertilizer and irrigation should be applied specifically to the crop rows. If you apply irrigation and fertilizer in non-crop areas and in between gap areas, obviously weeds will emerge and they can cause problem to the crops. So that's why selectively we have to go for fertilizer and irrigation application. The next option is physical methods. Physical methods, there are many options, includes hand weeding, hand hoeing, digging, moving, cutting, dredging, and chaining, burning and flaming, intercultivation and use of mulches. Then chemical methods, you know, herbicide, that is the most common method that we can discuss later. Then biological methods. Biological method is again slow growing and emerging field in the weed management practices that is getting importance in nowadays and also in future. That is using the biological agents, that is diseases, insects, to control the weeds. Then last one is integrated weed management. So after practicing these methods individually, we found many positive and negative effects. So that's why ultimately we came to the situation and fact that in any individual weed management practices will not work against the weeds for effective removal. So that's why there is a need to integrate different practices of weed management to control the weeds. So that is called integrated weed management. Yes, weed management strategies. Some of those cultural practices include soil solarization, tillage, mulching, cover crops, biological control, and herbicides application. So solarization. Solarization means, as you know, cover the soil with the clear plastic or any organic mulch, so that maintains up to 6 weeks. So in case of plastic mulch that heats the soil up to, that is high temperature up to 50 degrees Celsius. So you add that 50 degrees Celsius, that kills the weed seeds and other soil pests. So here you can see the solarization and flat surface, that is solarized bed. So before crop sowing, if you prepare such, you can prepare such beds and go for soil solarization. If you allow it for that is 6 weeks, so nearly 1.5 months. So you can see the clear effect, that is plastic not sealed into the soil and plastic sealed. So here, so there will not be any weed growth. So almost all weed sites died at the increased temperature of 50 degrees Celsius. That also reduces the diseases and insect incidents. Here we can see the solarized soil. So here you can see the clear difference. Beds after solarization. Here beds after solarization, there will not be any weed growth. This bed is clear. Here untreated bed. In untreated bed, any weeds can grow. So a conceptual model for an integrated approach of weed management, the prevention and tolerance of weed infestations enables the efficient use of therapeutic control measures. So here a conceptual model for IWM, prevention of weeds, seed bank management, residue management, allelopathy, and tillage. So these are the preventive measures in case of weed management. First one is seed bank management, residue management, allelopathy, and tillage. So by residue management, we can reduce the weed emergent. Then allelopathy, if you selectively use the crop having allelopathic effect or weeds having allelopathy, at least we can reduce some weeds. Then by tillage, these are comes under prevention methods. Then tolerance of the weeds. Then we can also have some idea on the crop weed threshold. Up to how much weed density I can allow in the particular crop, so that yield reduction should be minimum. Then enhance the crop weed competition, reduced weed fitness, then therapeutic control. So first we need to think on these two things, preventive measures and this crop weed biology, and then we can go for therapeutic control, mechanical, chemical, and biological methods. First we need to explore these two things, and then we can go for control measures in case of IWM. So one more thing is, I don't know you heard or not, the stale seed bed technique is there. Stale seed bed technique. A stale seed bed is a seed bed where the non-dormant weeds in the germination zone, that is shallow soil layers from which weeds can emerge, are killed before planting. Weeds emerge from the germination zone, depends on the weed species, wild type presence, and the crop. Here, in the case of stale seed bed technique, before planting up the crop, we are preparing the land and irrigating, and just we are allowing the weed seeds to grow. We are not going for crop sowing. So just we are preparing lands and irrigating the land. So just we are allowing the weed seeds to emerge. In case of favorable conditions, weeds will definitely emerge. What we will do after weeds emergence, either we can go spray, we can go for non-selective herbicides, or we can go for plowing. So here simple strategy in case of stale seed bed technique is, here we are allowing weeds to grow and we are destroying weeds after their emergence. So this is the mechanical, that is we can cultivate the weeds after growing and they can be incorporated to soil, and in other cases we can also go for spraying of herbicides. Then we can also go for chemical, that is fire, using fire. That is practice. Some of the advanced farmers are practicing. They are burning the feed seeds with the high temperature fire flame. So this is the IWM components. So good land preparation, then water management, biological control, weed control action indicator, then chemical control. So by practicing some of the cultural, preventive and other all the possible methods, so we can get the no significant yield loss due to weeds in case of IWM. This is the main motto of the integrated weed management, that is there should not be significant yield loss due to weeds. So this weed management we are attaining through combination of different uses. So again, that is spoken discussed on weeds. So then we can have a little discussion on some of the important, that is herbicide classification and mode of action. So herbicide classification and mode of action is itself a different topic. So just we can discuss few things, that is classification. Herbicide classification can be based on the chemical structure or family. For example, 2-chloro-N, these are the chemical names. Then based on the cropping system or ecosystem. Then third classification it can be based on mode of action, the plant processes and pathways inhibited by the herbicides. Why know herbicide modes of? Why to know the modes of herbicide modes of action? That is, why you have to know the mode of action of herbicides. So for better understanding of the herbicide performance, then to improve the herbicide performance and to diagnose the herbicide injury and prevent and manage the herbicide resistance. For these things, we need to know the mode of action of a particular herbicide. So herbicide mode of action, here we can see the after spraying at the weed leaves, herbicides can go into the leaves, then that leaves, if that affects the site of action, that leaves shows the toxicity symptoms, then weeds become dry. Then similarly absorption. So these are all the moments of the herbicides after application. After containing some of the herbicides also go into soil. Okay. So this is the site of absorption and translocation. For example, foliar contact, that is herbicide gramaxone, that is contact herbicide. Then root contact, some of the herbicides go into root, then xylem, then these are the site of absorption. That is, one is foliar, then root contact, then through xylem, then xylem and phloem, that is phloem roundup, then rangeland herbicides. So these are the different sites of absorption and translocation of the herbicides through which applied herbicides will act at the particular site of the weeds. So herbicide classification, selectivity. Based on selectivity, herbicides can be classified as selective, means that control or suppresses the one species of the plant without seriously affecting the growth of the another plant. So this is the selectivity. Here herbicides are selectively kills the weeds and they are not affecting other plants such as crops. Suppose 2,4-D. If you spray the 2,4-D on crop, in case of rice as well as wheat, this 2,4-D controls only broad-leaved weeds. They don't affect the grassy plants such as rice as well as weeds. So that is the selectivity. So if you apply weeds on herbicides and crops and as well as weeds, that controls only broad-leaved weeds. Then our next that is non-selective herbicides that control the plants regardless of the species. For example, if you apply the Roundup, that is glyphosate, that kills all the plants, whether it is crop, weed or whatever, that kills all the plants in case of non-selective, but it is not so in case of non-selective, that controls only selectively. Then some things to remember, that is photosynthesis, food, pigments, energy, light capture, respiration, that is energy, amino acids, proteins, growth and lipids, cell membranes and hormones, oxygen and others. So these are the physiological mechanisms involved in any particular plants to grow and perform better. So these are the some of the physiological important mechanisms that herbicides will encounter. Means herbicides will affect these one of these physiological important mechanisms in the weeds. So by that effect they control the weeds. So that we can see later. So classification based on the mode of herbicide action of that is group. Lipid biosynthesis inhibitors. Some of the herbicides are known to inhibit lipid biosynthesis. Then amino acid biosynthesis inhibitors, cell division inhibitors, synthetic auxins, then photosynthesis inhibitors, EPSP synthetase inhibitor, then pigment inhibitors, membrane disruptors, and some of the herbicides mode of action is still unknown or less known. Then herbicide mode of action groups. Group 1 is lipid synthesis inhibitors. This works in case of grass killers, that blocks the ACAGE enzyme. So here the ACAGE enzyme is known for lipid synthesis in case of grasses. So these herbicides will block the ACAGE enzyme. So that's why there will not be lipid synthesis in the particular fields such as grasses. So if lipid synthesis is not there in grasses, the grasses gradually die. So that is the mode of action of this particular grass killers, that is lipid by inhibiting the lipid synthesis. Then mechanism of resistance. So nowadays that is for all the herbicides, some of the resistance mechanisms we are getting, that is mainly due to altered target site. So that I discussed in the last class. So this is the altered target site. Then herbicide mode of action groups, that is group 2 is amino acid synthesis inhibitors, that blocks the ALS enzyme activity. Means acetolactate synthetase is an enzyme which is known to synthesize the amino acids, that three important amino acids that enzyme secretes in the plant system. Because of that, then what these herbicides will do, these herbicides will block the ALS, that is acetolactate synthetase enzyme activity. If herbicides block this activity, there will not be amino acid synthesis production in the weeds. So due to lack of amino acid synthesis production, weeds will die. The herbicides such as glean, tail, so these herbicides involved in the amino acid synthesis inhibition. Okay, then that translocates into new growth in xylem and phloem. Then plants stop growing shortly after application, but plants death may be 10. Okay, that is after this application, plants gradually slow down the growth, and after some times that will die. So ALS inhibitor symptoms. So this is the then fourth group is, that is synthetic auxins or overall natural auxin pathways. So that some herbicides stimulate to produce the excess auxin in the plant system, and some of the herbicides known to inhibit the auxin synthesis. By that, weeds will become die. Then these are the examples. Synthetic auxin symptom. So this is the effect of herbicides on different crops. Synthetic auxin symptoms. So twisting needles due to drift of triclophane. So next group is photosystem 2 inhibitors. So that directly blocks the photosynthesis. So if there is no photosynthesis, there will not be any further growth. So by that mechanism, weeds will be controlled. So here injures old growth first moves only upward in xylem and injure symptoms are allowing fluorescence of leaf tissue followed by death of the tissue, that is necrosis. Here we can see the herbicides which affect the photosystem too, that is chlorosis. This is necrosis, that is death of the leaves. Then consequence of photosynthetic inhibition. So you know the consequence of photosynthetic inhibition. There are many physiological and biochemical changes. Ultimate change, visible changes, photosynthetic plants, that is leaves will become necrotic and new leaves will die. Then some of the herbicides known to glycines, that is inhibit the amino acid biosynthesis. Glyphosate injury symptoms. Then bipyridiums, that is paraquat, known to divert electrons from the photosynthesis. So interesting thing is this herbicide is known to divert the electrons from the photosynthesis. So there will not be electron transfer, means there will not be energy availability. So by that mechanism, plants will die. Then microtubule assembly inhibitors. Some of the herbicides are not inhibit the microtubule assembly inhibition. So by that mechanism also plants will, that is weeds will die. Then why are not there any new herbicides? So far these are the different mechanisms found in case of different herbicides. Are there any herbicides which mechanism is not known or less known? As I told, some of the herbicides are there. Those herbicides exact mechanism of control is still less known, or in few cases that is unknown. All herbicides now on the market are well discovered by accident. So half of the current herbicides inhibit one of only 3 target enzymes. So new target based technologies may lead to new herbicides. So this is the herbicides mode of action. So there are many classifications. So I can also share this herbicides classification notes to you in terms of PDF. So you can also refer to that notes in remembering. Just suppose just to remember one points. Microtubule assembly inhibitors. What is the herbicide which cause the microtubule assembly inhibitors? So what is the group of herbicide which cause microtubule assembly inhibition? Similarly, what is the group of herbicide which affects the bipyridiums? Means that is the bipyridium group of herbicides paraquat that diverts the electrons from photosynthesis. Similarly, which group of herbicides inhibit amino acid biosynthesis? That is glycine or glyphosate. Like that, you have to remember. So just for your understanding, we are showing this much information. For time being, just you remember such things. So what are the herbicides which affects the photosystem too, which inhibit the photosystem too? So in bullet points, you need to remember the points for your examination. So this is the herbicide combination. Sir, shall I cover another 10 minutes?
Yes, please continue.
Yes, sir. Here one more thing is herbicide combinations. So first you need to know why there is a need of herbicide combinations. Because in weed management continuous we are using herbicides at the large scale. So what weeds inside there, because of many mechanisms and other hardy nature, they are going to diverting their site of action and other things. So somehow by some mechanism they are just escaping the herbicide effects. Herbicide and toxicity, they are just escaping. So that's why what scientists thought that Suppose if one herbicide, if you spray only one herbicide and that particular weed, that weed may escape from one herbicide. That's why we have to combine the herbicides in such a way that that weed should not escape. If you spray two herbicides in combinations instead of one, so that weeds will be definitely suppress or kill because of two herbicides. Suppose if one herbicide fails, another herbicide will kill the weeds. Okay, so this herbicide combinations is one of the important practices to reduce the shifting in weed flora or herbicidal resistance. So herbicide combinations are mixtures refer to mixing up two or more individual herbicides to control different classes of weeds simultaneously. Herbicide mixtures are used commonly in every crop, and now some new herbicides are being introduced as formulated mixtures. Herbicides may interact physically or chemically in spray solution and biologically in the plant. Many crops in the US and Europe are treated for more than 150 different mixtures in each season. So here herbicides we are mixing inbuilt in factory mixtures only, and some of the herbicides we are mixing just before application at the field only. And disadvantages of pre and post emergent herbicides. So why we are following these herbicide mixtures means there are some disadvantages in the pre-emergence as well as post-emergent herbicides. Those are effectiveness against the target species, then toxicity to birds, mammals, aquatic species, and other non-target organisms. Then herbicides that act on a single site of action, herbicide used for several consecutive growing season or repeated application of herbicides with the same site of action or same or different crops. Then these are some of the most important herbicide resistant species, that is ryegrass, wild oat, then green foxtail. These are some of the weeds has got resistant to different in herbicides. So that's why in order to avoid the herbicide resistant development, the herbicide mixture is the one of the possible solutions to reduce the herbicide resistance and shift in weed flora. Why there is herbicide combination is required? That increase the spectrum of weed control, that improves the broad spectrum weed, that helps in controlling the broad spectrum. That is, suppose if we mix two herbicides, we can control both grassy as well as dicot broadleaf weeds. Then minimize the development of weed resistance, reduction of the doses of the herbicides, then improve crop safety, reduces the environmental effect of herbicide in mixture, then prevention of detoxification and more effective and economical weed control. Then types of herbicide mixtures, pre-mixed formulations. This is made by manufacturers only. That is that comes in built mixture, for example, brush, booster, and there comes in different trade names. Then next mixture is tank mixtures. The tank mixtures made with the desired herbicides and rates just before application. So these are the examples. Then effects of herbicide interactions. Interactions, it is the term used to express the relationship of one agent against other in combination. Means suppose herbicide 2,4-D and one more herbicide, that is paraquat. These two herbicides we are applying independently on the same crop. Suppose 2,4-D on the wheat and paraquat on the wheat. So the effect of herbicides in individual application is different, and in mixture it will be different. So we need to test how it's affecting in case of mixture, whether it is additive effect, synergistic effect, or antagonistic effect. So that's why before going for herbicides mixture, we need to test their results, whether they are have any additional effects, synergistic means positive effects, or antagonist. Some of the herbicide combinations have antagonist effect. Individually they are perform better, in mixture they will not perform better. So that's why before recommending any herbicide mixtures, these effects should be tested. So here examples of synergistic effect. So this is the total effect of herbicides combination, which is greater than the predicted sum total of the individual herbicides applied alone. What I told earlier, for example, 2,4-D plus chlorpyrifos and that monocot species which is resistant to 2,4-D will be controlled. Atrazine plus alachlor in case of maize, paraquat plus triazines. Then for example for antagonistic is it is the total effect of herbicide combination then which is less predicted sum total of the individual herbicide. Here the combined effect is less than the individual effects. Here are the example. Then tank mixture herbicides. Tank mixture means here just we are mixing the herbicides at the field just before application. So in that condition, chemical incompatibility may be happen, physical incompatibility may happen, then loss of selectivity of a given herbicides may also happen. Then physical incompatibility. Physical incompatibility means that can be observed visually. Means suppose after mixing two herbicides, that herbicide mixture will become become hard, and because that becomes some other visible things. So by that only we can assess that these two herbicides are incompatible. Here we can also see separation of compounds into layers, then formation of gelatinous masses or suspended globules. So these are all the physical incompatibility symptoms we can see after mixing the herbicides. So methods to avoid incompatibility. So compatibility charts serves as an excellent source of information to help avoid these mixtures. So there will be chart prepared by the herbicide distributors. So which herbicides are compatible, which are not compatible. That chart will come. So by looking at that chart, we can go for herbicide combinations. While when making tank mixture of herbicides, their compatible need to be tested. So this is done by pre-mixing the materials by making slurry of small quantities, then before adding to the tank. If required, a compatibility agent which is non-ionic in nature may be used. Always pre-slurry wettable fodders. If added directly to the tank, globes or of unwetted material often occurs. So pre-slurry wettable fodders and add tanks, that is up to 3/4 of full of the water. So these are all some of the preventive methods to avoid incompatibility at larger scale. So herbicide compatibility and compatibility here, these are the examples. Whether they are compatible or incompatibility. Premix combinations. So these are all the proven examples. So this is the discussion what I thought to discuss with you people. So if you still require any other points to be covered, so any other points I left, so you can suggest so that we can think. If many things left remain, so we can think of covering and also if you need any other things, I can also share the possible notes I have with me. Okay, thank you, sir.